Hi friends, good morning to everyone. Welcome to my channel Belagali's class. Yes, my friends, we have started with factors, factor algebra, factors. Done one basic basic class, my friends. What I mean by factor, another quantity is there, that is a scalar quantity. How to represent a factor? A vector can be represented by a directed line segment AB. That length of AB, length of that line segment AB is called as magnitude of the factor AB, and is written as, yes, my friends. How we write it? That magnitude of AB is written as, I write here. Magnitude of AB is written as, yes, my friends, it is AB, which is nothing but length of the factor AB, or length of the line segment. This is the vector representation. You can see here itself, it is what? From A to B. Its length, my friends. This is a directed line segment. We represent the vector by a directed line segment. Length of the line segment is magnitude, is written as what? Magnitude of the factor AB. Then what is the magnitude of the factor AB? Is nothing but AB. That length AB is nothing but the distance between the points A and B. Length AB. Then what is the direction? Direction is from the point A to point B. That gives the direction of the vector AB. Therefore, my friends, remember, a vector can be represented by a line segment AB, in which that length of the line segment AB is known as magnitude of the vector AB, and is written as modulus of AB. Then this modulus of AB is nothing but length AB. So remember, this modulus is nothing but simply the length. AB can be represented as what? Modulus of AB, or modulus of AB can be written as EB itself. My friends, remember one useful result by this definition. Yes, my friends, that is a representation of a vector. Then, my friends, we went with what? Types of vectors. Zero vector or null vector. What is zero vector? That types we classify with the help of its magnitude. If the magnitude of the vector is 0, then that vector is known as zero vector or null vector. That zero vector or null vector is represented as what? Denoted as zero vector, or whose initial and end points are same. Whose initial points, my friends, everything is told. This is known as initial point of the vector AB. This is known as end point of the vector AB. Therefore, AA means what? Its initial and end points are same. Then what is its magnitude? Is 0. Either like this or like that. It is a zero vector. Then, my friends, unit vector. What do you mean by unit vector? A vector whose magnitude is 1. Length of that line segment is 1 unit, my friends. Therefore, it is known as what? A vector whose magnitude is 1 unit. Then that vector is known as unit vector. Unit vector I have written here, my friends. If OA equal to A is a unit vector, then what about its magnitude is 1? Its magnitude is 1. Magnitude of A is also what? 1 unit, my friends. This is the definition of what? Unit vector. What do you mean by unit vector? It is a vector whose magnitude is 1. Whose magnitude is 1. Yes, my friends. After that, I gave the definition of a resultant of vectors. With the help of the resultant of vectors, I defined triangular law of addition. Yes, my friends. What is a triangular law of addition? If AB equal to A is the given vector, BC equal to vector B is the second vector, then what is this AC? It is the resultant of the vectors AB and BC. Resultant of the vectors AB and BC, then that AC resultant represents the sum of the vectors AB and BC is written as AB plus BC equal to AC. What is your observation, my friends? The addition of two vectors exists only when end point of the first vector is same as initial point of the second vector. End point of the first vector is same as initial point of the second vector. Then what is its addition, resultant? What is that resultant? It is a vector joining initial point of the first vector to end point of the second vector, AC. This, my friends, no B, AC. Therefore, AB plus BC is AC, or vector A plus B is AC. Next, I give the definition of, my friends, parallelogram law of addition. Parallelogram law of addition. Yes, what is that? Let OA equal to vector A, OB equal to vector B are the two adjacent sides of a parallelogram OACB. Adjacent sides of a parallelogram OACB. Then, according to this parallelogram, this is the diagonal whose initial point is same as initial points of what? Vectors A and B. These three are what? Co-initial vectors. Then, my friends, OC represents diagonal. OC represents the sum of vectors OA plus OB or sum of the vectors A plus B. Diagonal OC. I told about the diagonal BA. That diagonal BA represents the difference. What is the difference? A minus B, not B minus A. A minus B. My friends, co-initial diagonal represents the sum. Other diagonal of a parallelogram, that is BA, represents the difference of two vectors, that is A minus B. Yes, my friends, these are the things we have done in the previous class video. Remember, these are the basic, my friends. One basic unit factor, its magnitude is 1. Remember, my friends. Now, what is second? Second is a triangular law of addition. What is this? If AB equal to A and BC equal to B are the two given points, then the resultant vector of these two, AB plus BC, is AC, direct. Joining this with this, vector AC is the sum of these two vectors, my friends. This is known as triangular law of addition. This is parallelogram law of addition. Parallelogram, it is a parallelogram OACB in which a diagonals having the co-initial point of these two vectors, that diagonal represents the sum of these two vectors. Other diagonal represents the difference, A minus B. My friends have given one more definition there. What is that? Unit factor in the direction of vector A. Unit factor, this is the vector A. Normally we have taken what? AB equal to vector A. Initial point is A, end point is B. This is the vector. Then this vector we cut with one. What is this? This is AC, or you can say anything. AC. What is its magnitude? Its magnitude is 1. Then that factor AC is known as unit factor in the direction of the vector AB and is denoted by cap, my friends. Therefore, unit factor A cap means its magnitude is 1. Its magnitude is 1. And my friends, remember, what is its direction? Is in the direction of the vector A, depends on this. Then this A cap is defined as A cap equal to vector A divided by its magnitude. Vector A divided by its magnitude. Yes, my friends, it is another definition. Definition of what? Unit factor in the direction of vector A. Unit factor in the direction of vector A denoted by A cap defined as A cap equal to the same vector divided by its magnitude. This is the definition of what, my friends? Unit vector in the same direction, these are the things already we have explained in the previous class, my friends. Just reminded. Then rest of the things we use these results, my friends. Then you are seeing next is what I want to do, the two properties of what? Vector addition. One, we have to show that vector addition is commutative. You know the commutative properties in case of real numbers. If A and B are two real numbers, then B plus A equal to A plus B. B plus A equal to A plus B. This is a commutative law with respect to addition. And BA equal to AB means B into A equal to A into B. What is it? It is a commutative law with respect to multiplication of real numbers, my friends. But we have an interest only in case of what? Addition is commutative. Properties of vector addition. First one, prove that the vector addition is commutative. Commutative, what is that property? For any two vectors A and B, prove vector B plus vector A equal to vector A plus vector B. This we wanted to prove, my friends. Let AB equal to vector A, BC equal to vector B. Yes, we have taken out of the given vectors. I use the triangular law of addition. By triangular law of addition, AB plus BC is what? Vector AC. But what is AB? A. What is BC? B. Therefore, my friends, A plus B equal to AC or vector AC equal to A plus B. You name this as one. Next, my friends, complete the parallelogram ABCD. This parallelogram completed. Then you know the property of a parallelogram. In a parallelogram, pair of opposite sides are equal and parallel. So AB equal to DC equal and AB is parallel to DC. What is the another pair? This. AD equal to BC. They are equal and they are parallel. See, my friends have written. Complete the parallelogram ABCD. Then in parallelogram ABCD, pair of opposite sides are equal and parallel. Therefore, AB equal to DC and they are parallel. Yes, my friends, magnitude is same and their direction is also same. AB, DC, their direction is also same. But what is AB? AB is A, my friends. Therefore, this is vector A. What is another pair? AD. This is AD and AD equal to what? BC. Magnitude is same and what, my friends? They are in the same direction. Then my friends, vector AD equal to vector BC. But what is BC? BC is B. Therefore, vector AD equal to this, my friends. And this is vector AD is vector B. Vector DC is vector A. Yes, my friends. Again, by triangular law of addition, direction is very important. AD plus DC. These are the two factors such that the end point of the first factor must be initial point of the second factor. Therefore, AD plus DC is what? AC. AD plus DC is AC. What is AD? Factor B plus DC factor A. Therefore, B plus A equal to factor AC. But what is factor AC by 1? Is A plus B. Substitute because by 1. Therefore, my friends, factor B plus factor A equal to factor A plus factor B. Therefore, addition of two factors is commutative. My friends, it is a 2 mark example. If the examiner wanted, he may give this. Factor addition is commutative. Yes, my friends, I will explain once again here itself. Let vector AB equal to A, BC equal to B are the two given vectors. Then by triangular law of addition, AB plus BC is AC. That is, A plus B is AC. Therefore, AC is factor A plus factor B, my friends. Name this as 1. Completed the parallelogram. Parallelogram means property of the parallelogram. In a parallelogram, pair of opposite sides equal and parallel. Equal means their magnitude is same. Parallel means their direction is same. The two vectors are said to be equal if they have their magnitude is same, their direction is same. If the magnitude and direction of two vectors are same, then those two vectors are equal. Therefore, my friends, magnitude, direction, vector AB equal to vector DC. But what is vector AB? Is A. Vector AB is A. Similarly, another pair AD and BC equal and parallel. Factors equal, but what is BC is B, so it is B. Now, again by triangular law of addition, AD plus DC equal to AC. I told my friends while explaining triangular law of addition exists only when end point of the first factor must be same as initial point of the second factor. Now, for these two factors, D is same. Therefore, it is AC, my friend. But what is AC by 1 is A plus B. Therefore, B plus A equal to A plus B. So, addition of two factors is commutative. This is first one. My friends, the second property. Factor addition is associative. For any three factors A, B, C, prove factor A plus factor B plus factor C equal to A plus B plus C. This associative law, commutative law, distributive law, all these things, my friends, we have explained with respect to number system. We have done all these things, but these are basic formulae, basic rules, you can tell. Basic rules, basic laws of real numbers. This is associative law with respect to factors, my friends, factors. We want to prove this. Let OA equal to vector A, AB equal to vector B, BC equal to vector C. OA, vector A, AB, vector B, BC, vector C are the given vectors. Join OB, OC and AC. Join them. I have written join OB, OC and AC. I have taken one by one. It is a LHS. What is LHS? A plus B plus C. This is LHS. Substitute the values. A is what? OA. B is AB. Plus C is BC. Again, by my friends, by triangular law of addition. Once again, triangular law. It is a basic law. OA plus AB, C. These are the two factors such that end point and initial point of the second vectors are same. If it is so, what is their addition? OB, resultant, plus BC, same. OB, BC, end initial same. What is this addition? Resultant, which is vector OC. Therefore, my friends, vector A plus vector B plus vector C equal to OC we have proved. Name this as 1. Other side, this is a RHS C. What is RHS? Vector A plus vector B plus vector C. Substitute their values. OA plus AB plus BC. Bracket. Apply the triangular law of addition. Yes, again end initial same. It is AC. Once again, my friends, here also it is because of the triangular law. Again, what is this? Once again, triangular law. OC. Therefore, A plus B plus C is OC. Name this as 2. Comparing 1 and 2. OC. RHS are equal. Therefore, LHS of 1 must be equal to LHS of 2. So we have A plus B plus C equal to A plus B plus C. Therefore, this proves that factor addition is associative by this as well as, what is this one? Commutative. Therefore, factor addition is both commutative and associative. Both commutative and associative. Yes, my friends. I give 2 minutes. Copy. Copy. Yes, friends, I told many times while copying, please be fast. Copy the things fast. Even that will help in your exam also. You can complete your paper in time. In time. Yes, friends, I hope you have completed that side, that first property. Yes, I will remove that first property, open, copied. Then I go with the next definitions and related examples, results. Yes, my friends, for this second year, started with factors. Factors. Next definition, my friends. Definition now, scalar multiplication. Scalar multiplication of a vector. Scalar multiplication of a vector. Yes, my friends. You know what I mean by scalar? Your numbers 1, 2, 3, 4, 5, all the set of real numbers is a scalar quantity. I tell my friends, what I mean by scalar, which has only magnitude, no direction. For the numbers, my friends, there is no what? Direction. Therefore, the set of real numbers is a scalar quantities. Yes, my friends. What is the definition? Let A be the given factor. A be the given factor. Given factor. And K not equal to 0. K not equal to 0. When K is not equal to 0 means K may be positive or K may be negative. May be positive, may be negative. B, the scalar. Then, my friends, scalar multiplication of a vector. This is K. What is your factor A? Then, what is this K into A? it is a scalar multiplication of a vector. Scalar multiplication of a vector. Then what is it? It is a vector. It is a vector whose magnitude, vector means comes both, whose magnitude is k times that of vector A, and direction is along vector A if k is positive, and opposite to that of vector A if k is negative. Yes, my friends. If this is the vector A, 2 times means what, my friends? Double. This is the vector where we have multiplied by what? Ka. If k is positive in the same direction, if k is negative, it is in the opposite direction. Yes, my friends. What is the scalar multiplication of a vector? If A is the given vector, k not equal to 0, scalar quantity, then Ka, my friends, remember, Ka is what? Scalar multiplication of a vector. Scalar multiplication of a vector is a vector, it is a vector quantity whose magnitude is k times the magnitude of 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 that of the vector A, magnitude of that of the vector A, and the direction is along vector A, along vector A if k is positive, opposite to A if k is negative. This is the definition of what, my friends? Scalar multiplication of a vector. Scalar multiplication of a vector. Yes, my friends. Yes, copy it. Next definition is position vector of a point. Next definition is position vector of a point. This is another important definition. Position vector of a point. Yes, my friends. We have to define its position vector of that point. Yes, my friends. Point is there. In this case, we take, let O be the origin of reference which is arbitrary. Let O be the origin of reference. That particularly this intersection is one particular case, but in this case, this O is what? Arbitrary point anywhere. If I take here, this side, that side, anywhere you can take. And P is any point. This P is the given point. Then the factor OP, tell my friends, what is this factor OP? It is a factor. What is its direction? Direction is from the O to point B. Then this OP is known as, factor OP is known as, you can take point P here, this is point P here, anywhere you can want it. Then this factor OP is known as position factor of the point P. Position factor of the point P. Yes, my friends. Let O be the origin of reference. O be the origin of reference. which is arbitrary, point, and P is the given point. P is the given point. Then vector OP, tell my friend, it is a vector whose direction is from O to P. Then OP is called position vector. Position vector of the point P. Position vector of the point P. Yes, my friends, copy it. I will explain once again. Position vector of the point P. This is very important with respect to origin of reference O. With respect to O. Yes, friends, copy it. Hope this is completed. Associative property. Yes, friends. What is the position vector of a point? This plays always a very important role in vectors, my friends. Let O be the origin of reference, which is arbitrary point. Means you can take anywhere, this side, that side, not necessarily with that point of intersection of two perpendicular lines. That is a particular case of what? This. Generally, OB is the origin of reference, which is an arbitrary point, and P is the given point. Then the factor OP, you can take either this way. If you wanted, even you can take towards this side also. Yes, my friends. This is the point O. Then this is the point P. Then this is your factor OP. You can take like this, anything. This is the point factor OP. Then that factor OP is called as the position vector of the point P with respect to the origin of reference. With respect to the origin O. Yes, my friends. Next, you have one result which is very, very useful result. Very useful result. Yes, my friends, I do that result, which is very important, useful result. Yes, my friends. If A and B are any 2 points, if A and B are any 2 points, any two given points, and O is the origin of reference. O is the origin of reference. Then prove factor AB equal to factor OB minus factor OA. Then prove factor AB equal to factor OB minus factor OA. Yes, my friends. Yes. A and B are the two given points. Yes, my friends. Take. This is the one point A. This is the other point B, second point. This is your factor AB. AB means what? The direction is from A to B. Direction is from A to B. Yes, my friends. And this is O is the origin of reference. This is, you can take anywhere. O is the origin of reference. Then this is factor OA. This is factor OA from O to A. What is this? Factor OB. It is from O to B. Yes, my friend. This is OB. Yes. A and B are the given points. EB is the factor. O is the origin of reference. Then OA and OB are the position factors of the points A and B. Let's write the same, my friends. Right. Let A and B are the given points. Are the given points. Are the given points. Then join AB. AB is the factor. Let OB be the origin of reference. OB the origin of reference. Then factor OA and OB. Tell my friends, are the position factors. I write in simple position factors PO. Position vectors of the points A and B. Position vectors of the points A and B. Position vectors of the points A and B. Yes, my friends. Then what is this AB? AB is the given factor. AB is the factor. Yes, my friends. Again, useful friend is triangular law. By triangular law of addition, triangular law, we have, yes, direction OA, AB. What is this? These are the two factors. End and initial points are same. By triangular law of addition, factor OA plus factor AB. See friends, end points, initial points are same, then factor addition exists. What is this? This is nothing but what? Resultant. Initial point of the first factor to end point of the second factor, that is OB. Yes, my friend. Therefore, from this, what is AB? For simple simplification, AB is what? This is OB minus OA. Shift that OA that side. Therefore, any factor AB can be represented in terms of its position factors. What is RHS? Position factors of the points A and B. What is AB? AB is the factor. Therefore, from this result, my friends, any factor can be expressed in terms of what? Position factors. A factor can be expressed in terms of position factors. How? Position factor of the second point first. Position factor of the second point minus position factor of the first point. Therefore, any factor AB can be expressed in terms of position factors as what? Position vector of the second point first minus position vector of the first point. Similarly, yes friends, similarly, what is this? Vector BC. Vector BC. This is what? Position vector of the second point minus position vector of the first point B. Okay. Like that you can write any factor we can express. First, position vector of the second point minus position vector of the first point. This is another very, very, very useful result, my friend. Any factor AB can be written as OB minus OA. Any factor can be expressed in terms of position factors. Position factors. Very useful, important result. Even this result, if they wanted for the board exam, they may ask under 1 mark question, 1 mark question for the board exam. I told on the factors you have 1 mark, 1 example, 2 mark, 2 examples, and 3 mark, 2 examples. Totally 11 marks, my friends. So this they may ask under 1 mark question. 1 mark question. What is it, my friends? Let A and B are the given points. Then AB is the vector. AB is the vector whose initial point, end point. AB is the vector. Let O be the origin of reference. Then OA and OB are the position vectors of the points A and B. Yes, now we have the cinema picture. Figure by triangular law of addition, OA plus AB. OA plus AB is OB. By triangular, shift that side minus OA. Therefore, AB equal to OB minus OA. Therefore, any factor can be expressed as what? Position vector of the second point minus position vector of the first point. Second minus first. This is one useful result, my friends. Useful result. Then connected with this, I do one example. You know the scalar multiplication. What is scalar multiplication? Just you have to multiply with that number k into a. K into a. This is position factor. Then it is the result. Yes, friends. Next one example connected with this. Yes. If the position factors, my friends, I write in a brief, position factors, PO, position factors of the points, position factors PV of the points A, B, C are respectively factor A, factor B and 2A minus 3B. 2A minus 3B. Then express factor AB and AC in terms of factors A, B, C. You have to find their values in terms of this. Let O be the origin of reference. O be the origin of reference. Then given yes, position vector of the point A. What is position vector of the point A? Is OA equal to factor A. Then OB is given. Position vector of the second point OB is factor B. And position vector of C, OC. This OC is given as 2 times vector A minus 3 times vector B. Then you wanted AB in terms of ABC. Yes, my friends. So now, factor AB. Apply this. Position vector of the second point minus position vector of the first point. What is the value of this AB? OB is factor B minus OA is factor A. Therefore, AB is expressed in terms of the vectors B and A. Similarly, you wanted another is AC. Factor AC. Yes. It is position vector of the second point minus position factor of the first point A. Put the values. What is OC? 2A minus 3B. 2A minus 3B minus OA. What is OA is A? Simplify it. 2A minus A factor A minus 3B. What is this, my friend? Factor AC. Just one more questions they may ask. One more questions they may ask. Yes, my friends. After this, I want to start with another very important useful result, my friends. Useful result. Yes. For that, yes. For that, yes, my friend. Yes. Yes. Okay, it's a little lengthy. So that result I do it in the next class, my friends. Yes, but I want to give the definition of this once again. I will remind it and I use it in the next class, my friends, next class. That result, that definition is if you want, you can write once again the definition. Yes, my friends. You can write once again the definition. Yes. The definition is, now you know about the unit vector. Unit vector in the direction of vector A, in the direction of vector A is denoted by A cap and is defined as A cap equal to factor A upon its magnitude. Yes, my friends, here is the figure. This is your factor A. This is your factor A. Then, what is this A cap? Along means this. Its length is 1 unit, its magnitude is 1, it is strictly given A cap. Maybe along, even this A cap may be parallel to A. Even this also, my friends. This is the factor, unit factor in the direction. Direction means what? Maybe along or maybe parallel to A. Maybe along the factor A or parallel to the factor A. What is the definition? This A cap is factor A divided by its magnitude. This is a very important result, my friends. Very important results. With the help of this, even you can simplify this as what? Therefore, factor A equal to, bring this side, this is, yes, this gives, this is A cap into, magnitude of A is factor A. Therefore, this man, any factor can be expressed. Any factor can be expressed as what? In terms of its magnitude, or A cap into magnitude of A is that factor A. This is another result, my friends. I use it. This is one. And another thing that I use there is about the factor. This factor can be expressed in terms of a ordered pair, my friends. A factor Yes, position vector of the point, you can say. Position vector of the point. Position vector of the point can be expressed or can be defined, anything can be given in terms of an ordered pair, in terms of ordered pair xy, ordered pair xy. A position vector of the point can be given, can be expressed, can be given in terms of what? An ordered pair xy, means if O is the origin of reference, P is the point, then this vector OP can be given in terms of what? Ordered pair xy. Yes, my friends, we shall see the rest in the next class, my friends. Till then, it is enough today with this class. Yes, my friends. Thank you very much. Enjoy. Yes, my friends. Till the next class, have a good day. Namaste, namaskara, my friends. Namaskar. Good day.